around in the market on the social media. That's it's a really very good model. So this DeepSeek R1 model, this is the basically a family of models. So R1 is stand for, I think it's related to the reasoning. I was checking that the praise this abstract uh, DeepSeek model, how exactly it's working behind this. So the main things that we can see, it's using the reinforcement learning to understand the capabilities of that LLM models to get that idea what exactly the user is asking about before going to calculate and each and everything. So instead of doing that fine tuning, so that we can get the idea to get that more details from existing LLM model, right? Like Llama, OM, GPT, and other, right? But if you can see that on the different mm, uh, sections, you can see like ME204 code force and all. So yeah, it's a quite good. You can see the blue one is the DeepSeek, right? So there is one more thing that I would like to discuss about this logo, right? So it's a whale. So DeepSeek basically they are trying to see that the whale can go deep in the sea, right? To understand that the flow and the algorithm, right? So in the context of AI, they are talking about how exactly this whale can go to understand that your questions and then do the reasoning capability around that to give the solutions. And yeah, the background is that again we'll say that it's a transform model only. So to understand the transformer model, you will have to go this research papers. Attention is all you need. And here we have a transformer models. Most of us we are already knowing about that because transform is uh, was introduced to us in 2017, I think. So we'll go this. We'll understand about this one little bit, but not whole context, while understanding the DeepSeek model as well. And but before that, we are trying to see how exactly it's working. So if we'll go here on the, I've downloaded the DeepSeek R1 Distill Quan 7B, so it's taking the from Quan only and distill that so that we can use it either locally. And rest of the thing, if you'll see that the supported endpoints is same like OpenAI, like so it's each and everything is OpenAI only. So we'll only have to change that endpoints to get the details. And yeah, definitely the OpenAI the key API key is also required, right? So I just downloaded it here and running it the same IP ports that we can see is here. So these are the things that I was trying to record this video, and we'll go through this as well. So again, my goal is to show earlier I had created one code related to you use that Copilot, right? So we'll see that how exactly it's behaving when we will use that uh, this DeepSeek model. So let's see, and in the meanwhile we'll also understand till the time it's trying to give that response, we'll see how exactly it's working. So let's see. So I'm trying to run this code, the Copilot code, and this time we'll use this DeepSeek model only. So if we'll go and check that code itself also, so this is not optimized code. So guys, pardon me on this. So you can see this. I'm uh, trying to talk with Llama 3.2. This is the endpoints which we are communicating with, right? And this you can see the endpoints is same only because we are using it locally. Rest of the things is same, only things we have added this model, right? The local LLM models. The same thing we'll have to apply there when we will use the exact OpenAI sorry, DeepSeek model, and the rest of the code will be same only, right? So but yeah, the response may we'll have to tweak that the response as well, and we'll see how exactly it's working. So uh, now this is our codes to understand how exactly this code is all about. We have already checked that it's how exactly it's working for the llama, right? And the core of all these models are the transformer only. We'll understand a little bit about that so that we can understand how this LLM is working, right? So let me check that suggest me, and this time we'll use the DeepSeek. I'm not passing any local model path. Let me save this one. So let's go here. You can see this, right? So the running chat completion. See, one message it received, and you can see it's starting generating. So it will take some time, right? Earlier when we used that the llama, it was quite fast. The other model, because there are other layer of abstractions that added here before generating that response is reinforcement learning, so that uh, the agent can understand. Okay, we'll go on that. So how exactly it's working? So when we ask that question, it goes to the reasoning model, right? And the reasoning model is basically the LLM agents will reasoning with each others to understand what exactly it's all about. We'll go how exactly this part is working. So this is the thinking parts which is introduced to understand the questions, and then give that rewards on the basis of the response only. And behind the scenes, yeah, we have a transformer as well, and this working yeah, this transformer is also working, right? So let's understand before going to the transformer. So let's understand how exactly we are working. And this one is working. So let's assume not this one. Let's see like this one, right? So suppose we are asking this question to solve this 8 minus 3 is equal to what? So how exactly it works? So first of all, it will tokenize this, right? We know that tokenizations means what? So tokenizations is basically the creating the computer understand then in the form of number only. So the first goal is to make this input to that LLM model is to make the tokenizations to convert that into a specific one. There are lots of tokenizers algorithms is available in the market, like for like TikTok and right, to convert that then individuals into that number, right? And then each individual's numbers will have to uh, see that the vectors, right, to pass it to create that embedding. So like a word to vec embedding we have. So with respect to each and every word in the tokenization, will pass it to the vectors. So to that embedding model, right? To get that vector of individuals word, right? Because the transformer, we pass the transformer in the parallel, right? And there are lots of things that are involved here. So we can, you can go and check that, right? So once you pass the tokens, it goes to this input embedding model. So input embedding models, like let's consider word to vec. So it's create that embedding. Embedding is nothing but whatever the number that we have passed, means the tokenizer parts of that the questions, it's convert into that numbers, right? And then it's let's assume we are using word to vec to create that embedding. So uh, so as per this model understanding, it's suggesting for the 500 tool, right? 512. So the dimension of this input model will be 512, right? The dimension, when we are saying the dimension, it means that on which context this number is getting generated with respect to that, what will be the um, numbers, right? So we'll discuss about when we will have a session related with the transformer, and then positional encoding. Encoding is incorporated because we are going to process that whole number embedded models in parallel. So so that we can understand the sequence of the words before passing into uh, this encoder, right? And then we'll pass it to the decoder only. So this is the transform model. We'll go and check that. But there are other layers of abstraction that was added is the related with the reinforcement learning uh, to understand that. So let's see whether it's still generating or it's still taking time. So it's still generating, right? So it's taking time to generate that. So let's see how the chat DeepSeek is actually working. So let's assume these questions only, where was that? Yeah, let me copy. I am not copy. Let me copy and ask this question to DeepSeek, and let's see how exactly it's working. So see, this is one of the thinkings. So I need to solve this 8 minus 3. So let me think subtractions. So it's understand that what exactly user want to get that from this input, right? So all right, 8 and 3 are taking away, so let me visualize this. So if 8 apples, someone is taking 3, and then so it's doing some reasoning work, right, to understand what actual the user is, wants to get that, right, from that individual question. So the solution will be this one. So and behind the scene it's converting into the numbers, tokens, then tokens passing into that embedding the reasonings, and all the reasonings involves here with respect to this diagram only, right? And then and how exactly it's working. So there are reward models. We have there are already reasoning tasks where this environment is working, means reasoning models. We know that how exactly the RL model is working. So whatever that we ask that question, it gives us some rewards, and then we train that to understand that okay, we'll have to understand what will the output. So on the depending on the awards only. Uh, in that particular environment, uh, we understand change that our algorithm, means not the algorithm but basically the way to get that the maximum reward in that particular environment by for that agent, right? So yeah, behind the scene this is the actual high level diagram, and let's see uh, the DeepSeek model. It's ready, right? So let's see how no, now you can also see that earlier it was a thinking, now it's thought process. So the thought process is working to understand the questions and the reasoning behind that. Reinforcement is learning, reinforcement learning is working behind that as well. And yeah, at the bottom layer the transformers are there, right? So we have that answer. So let's see the output. Yeah, we have received that output, and you can see this. See how exactly this model is working behind this. So okay, I'm trying to understand this is C sharp code. This is the C sharp code that we passed it to this DeepSeek model, and and that someone wrote. It is using for the Redis operations. So we'll see that the first code. Let's understand the code first. So we are trying to come save that Redis models to get that value. If that value is not available, then we save that in the Redis, and if that is available, then we are trying to get that values from that uh, that context, from that context only, right, from the cache data. So the same thing it's trying to understand. So okay, I'm trying to understand this C sharp code that someone has wrote, uh, someone wrote it, and it is using some Redis operation which I remember I had used to handle the key value data store. The code seems to be the part of the larger applications, maybe an e-commerce site where orders are stored. So it's trying to understand that what is code is all about, and then try to understand that the how exactly we have written that code, and suggesting some changes as well, right? So these are the things that it's trying to, when you will build an agent based model, so you will understand what exactly is working on. So this is the one agent which is trying to maximize that rewards on the basis of whatever the questions that we are asking, and when we ask that questions is converted into tokens. The tokens passed as tokens means the number, right? So this number passed to that model then try to understand that questions, apply some reasoning over that, and then depending on the questions, it's thinking, right? Reinforcement learning, thinking that what we are going to do, that the reasoning process is working on that, and then we get that response, right? So there are some improvement suggestions that it's suggesting, right? to improve that code version. So this is the improved versions that we are also getting it. So this is the few lines of code that we have written, and we have asked that to improve this code and suggest me some. So first of all, is trying to understand that, then give that the improvement suggestions, and this is the improved version of this code, right? So to maximize that, and these are the things that we have and let's apply it so we can see this. There are some code changes are required. So, yeah, we can see it. So because this is sending it this response in the JSON format, this format, so we'll have to first comment this, we'll have to comment it out, or we can take it this thinking tags from here. So we'll have to make some modifications in my codes to so that we can remove this thinking part, right? Whatever that we are getting in the from the DeepSeek. But overall code will the same only. If we'll go here, rest of the code will be same only. You can see this, right? Returning the tuple right now to get the response either from this DeepSeek or from this Llama, right? 3.2, this local version, and the same for the OpenAI as well, right? Everything will be same only. Only things will in the case of this one, we'll have to tweak some in our code so that the response, since we are getting the response uh, with the thinking tag as well, we'll have to take it out so that we can so depending on our use case, we'll have to think about that how exactly we are going to take out that response from the DeepSeek. But overall it's a very good. What I observe, it's slow because of the one of the reasoning layer it's introduced, and behind the scene there is a reinforcement learning is working um, to get an idea how exactly it's working. Then it's passed to um, the models to understand that, to get that weightage and understand that what we have to solve it, and give the rewards to that agents to get the maximum rewards. Then instead of fine tuning with respect to that our questions area, it's trained uh, it's a trained on that reasoning, a huge large reasoning data set, right? So overall it's a very good as of now. Will I will try to get more knowledge on this and try to understand more, then we'll go through this. And yeah, and the next session I will try